Hey guys, Mr. Taylor here from Rocking Math. Let's talk about quickly a proportional and non-proportional relationships using this activity on circles and squares. Well, what I have for you is, especially on question number 1, is I have a set of squares. Actually, they look like dominoes. Let's just call them that. But in one side of the dominoes, we have circles, and in the other side of the dominoes, we have squares. So what we want to do is determine, do we have a proportional or non-proportional relationship? We've talked about that, and we say that what we're going to do is we want to make sure that we have something that's proportional. That means if we set up a ratio, that ratio is going to be the same throughout the series. So let's take a look at the very first domino. I see 1 circle and 2 squares. So if I look at my table of value, it says let x be your circles and y be your squares. So I'm going to get 1 and 2. And if I look at the second, I see 2 circles and 1, 2, 3, 4 squares. So now I have the number 2 to 4. Then I have 3 circles and 1, 2, 3, 4, 5, 6 squares. So I'm having 3 to 6. Then I see 1, 2, 3, 4 circles and 1, 2, 3, 4, 5, 6, 7, 8 squares. Okay, so I've charted all of these on my table. And number 2 says, well, is there a constant proportionality? What they're asking, is there a number that is the same throughout what we've done? Is this number proportional? So again, if we do our, how can we do it? If we do our output over our input, we're going to have y over x. And if we have y over x, I am looking at 2 over 1, 4 over 2, 6 over 3, 8 over 4, which give me a proportionality that they all equals 2. Okay, so yes. And it asks, what is it? So what I did was put it at 1/2, and I did it by the ratios. But if we do output over input, we're going to wind up with 2 over 1. So my proportionality is actually 2. So we can actually look at that and justify it once we do our output over input. Okay, now the next thing it asks me to do, it says if the table of circles and squares is proportional, we need to write an equation. So let's look at, as I pull it up a little bit for us, let's look at an equation. So I see, going back down, I see 2 times n, because the common difference here is 2. So my equation would be 2 times n. If I put 1 circle and multiply it times 2, I'm going to get 2. If I have 2 circles and replace it with the n, I'm going to get 4. 3 circles, 6. 4 circles, I'm going to get 8. So now what I want you to do, and I feel like we'll change this up and do some work. It says to draw 4 rectangles using the information in question 1. So we want to go back up here to question 1, and I want you to draw for me 4 rectangles and use the number of circles from question 1 as the width, which means we're going to go this way. Let me put my pointer back. So that means we're going to go this way, and that means that if the width, then the number of squares is the length. So you want to make sure you draw me 4, and then of course if the width, the number of circles, so that'll be 1 and that'll be 2 for an example. Okay, now after that it says, are the rectangles similar? So you should know that you're going to have one that's proportional to the other, and you should be able to do that. Then of course number 5 asks us well, actually 5 is similar. Number 6 says to graph the ordered pairs. So what I did is I took those ordered pairs and graphed them, and as you can see, it creates a straight linear line that runs through 0, 0, and that's what it tells us. One of the criteria for it to be proportional, that it has to run through 0, 0. And 7 says name the dimensions of the other rectangles that would be similar to the rectangular graph. So all you got to do now is graph and then look at your other rectangles to determine how you would justify your answer. All right, seems like a pretty decent activity for you, and I will see you soon. Bye-bye.